Hello. In this video, I'm going to talk about the graphical approach of adding vectors. But before we do that, I want to define what a vector is. So I'm going to start with a scalar. A scalar is basically just a physical quantity with units. So basically, we can say 5 liters. We can say 2 miles. We can say 3 kilograms. All these are scalars. Basically, it's a quantity that only needs a number and a unit to describe it. But there are some quantities that need more than just a number or a value and units. They need direction. So if I say I'm driving 50 miles per hour, I'm driving at 50 miles per hour, I'm not pretty much giving you where I'm going. But if I say I'm driving at 50 miles per hour on the Palisades Parkway South, then I'm giving you direction. Or if I say I'm walking, I walked yesterday, I walked 3 miles north, then you know exactly which direction I walked. So once you add a direction to a quantity, it becomes a vector. That's pretty much what the definition of vector. Now, we need to represent this quantity on paper. And the way we do that, so I'm just going to give you an example. So let's say I have a vector v equals 20 miles per hour and at 20 degrees north of east. Well, the first thing we have to do is we have to figure out a way to represent 20 miles per hour on paper, and we have to figure out a way to represent the direction. So the way we do that is that we draw a map. And when we do this in class, you'll have to draw this perfectly, otherwise you're going to be off. So these two lines have to be perpendicular. So this is east, this is north, south, and this is west. So if I'm going to draw this, I have to go 20 degrees north of east. So I start at the east, and I start heading towards the north, and I do 20 degrees. So I'm going to put my protractor, the center of my protractor here, the 0 here. But the bottom line, it doesn't have to be the 0 here. The bottom line is that this angle here has to be 20 degrees. So I'm going to say, okay, you know what? Maybe it's along this line. So that's my dot that I do with the protractor. Now I have to say, well, you know what? How do I represent 20 miles per hour? I create a scale. So I say, you know what? Every centimeter is equal to maybe 4 miles per hour. So I'm going to need 5 centimeters. So my vector will be 5 centimeters long. If I had said 5 miles per hour, I'll just make it 4 centimeters long. So the scale that you choose depends on these numbers that you have here, and it also depends on how much space you have. So for instance, if this was 200, a scale of 1 to 5 is not going to be good enough, which means I need 40 centimeters on paper. I don't have that kind of space. So in that case, maybe I'll say, well, if this is 200, I'll say 1 to every 50. Then that's reasonable. I can draw that on paper. That's pretty much how we're going to do it. So now I'm going to show you how we add vectors. So I'm going to pick 2 vectors. So I have them here. So I have, let me just start all over. I have 2 vectors. V1 here is going to be 50 meters at 30 degrees north of east. Okay, and this is going to be V2 is 30 meters at 40 north of west. Okay, now how do we represent this? Well, okay, so what I want to actually do is that I want to find V1 minus V2. Now, when you subtract in a vector, just like in math, it's like adding its opposite. The question is, what's the opposite of a vector? Well, that's easy. The opposite of a vector is a vector that has the same magnitude as the original vector. It's just like 180 degrees in direction. Okay, so this is going to be 30 meters, not negative 30, at 40 degrees. Now the north becomes south, and the west becomes east. So this is how we add them. And I'm not going to do this fully because I have to show you some techniques in class. So I'm going to start here. This one is dead. I'm going to start here with V1. So V1 is 50 meters at 30 degrees north of east. So I start here and I do 30 degrees with the protractor. And I say, you know what, maybe 30 degrees is right there. and I have to represent the 50 meters. So in this case, maybe I can do, I don't know, maybe I can do every centimeter is 10 meters. Again, it just depends on how much space we have. What I'm going to do on the board is different than what you guys are going to do on paper because I have a lot of space here. So I'm going to draw the first one. So this is my V1. Okay? Again, this is just a sketch, and I'm going to show you how to do that. Now, here is the most important part. What I'm going to do now is that when you add vectors, we do what we call head to tail method. So now this head becomes my new origin for this vector here. So I come here, right? And technically I should have like another map, but I'll show you some techniques where you don't have to draw this again. There are some techniques. We'll use some geometry tricks. And then I'm going to draw, not V2, the opposite of V2. So I'm going to go 30 meters south of east. Well, east is this way, south is this way. So I'm going to go 30 meters at a 40 degrees. So maybe 40 degrees right there. And we'll do it exact in class. Then I'm going to do 30 meters. So maybe like that. Okay? So this is not V2, this is negative V2. Okay? Now if I was just adding V2, if I was doing V1 plus V2, I will not reverse this. I will just do 40 degrees north of west. Well, this is west, this is north. I'm just going to go 40 this way, which is basically going to be the opposite of that. Now, your answer is what we call the resultant. And how do you find the resultant? And this is important. You connect the very first starting point to the very last arrowhead. And you can do this with multiple vectors. I could have done V1 plus V2 plus V3 minus V4. I can do all that. And we'll get a chance to do that in the lab. So this is my resultant. Now, how do I find my resultant? Well, I would measure the length of it, okay, with a ruler. And based on the scale that I set to myself, I scale it back up because I had to scale everything down. I have to scale it back up to give it the true value. And then I'll measure the angle. If I'm close to the east, I'll measure this angle. If my resultant happens to be here, I'll measure this angle. It just depends. But all the angles will be measured with respect to east and west. It's just a matter of choice. By convention, that's pretty much how most textbooks do it. Okay? And that's pretty much vectors in a nutshell. And we'll do vectors resolution, which will use more math than just protractors and rulers. Okay, thank you.